Hi, till now in Greedy Technique I discussed knapsack problem, job sequencing with deadline. Next I will discuss optimal merge pattern. If two or more files are present, how we can merge by using two-way merging that will get less number of record moment. That's all about optimal merge pattern. When two or more sorted files are to be merged all together to form a single file by using two-way merging method, the minimum computation are done to reach this file known as optimal merge pattern. We can do n-way merging, but this optimal merge pattern is about two-way merging. Let's first understand what is two-way merging. In two-way merging, we'll merge two sorted files. File A already sorted, file B already sorted. Now I will merge these two files and I will create another new file. Let new file equals to C. So I'll compare 4 with 3. 3 is lowest, that I will move one comparison. Next I will compare 4 with 7. 4 is lowest, I'll move 4. Next I will compare 7 with 8. 7 is lowest, I'll move 7. Next I will compare 8 with 12. 8 is lowest, I'll move 8. Next I will compare 10 with 12. 10 is lowest. Next I'll compare 11 with 12. 11 is lowest. Next compare 15 with 12. So 12 is lowest. Next I'll compare 15 with 18. 15 is lowest. So this file is finished. Next I'll just move 18, 21, 22. So total number of record movement equals to size of file A plus size of file B. Here 5, here 6. Total 11. So we moved 11 files from file A and file B together. And total number of comparison is 7. I just compare this 5 file with this 3. After that I just move these 3. So total comparison is 7. Number of record movement equals to size of A plus size of B, or you can say M plus N. If M equals to size of first file, N equals to size of second file, and number of comparison equals to M plus N minus 1 in worst cases. Maximum it will be M plus N minus 1. This is important. Number of record movement equals to M plus N and number of comparison equals to M plus N minus 1 in worst case. Let's see another example having more file. F1 size is 5, F2 size is 18, F3 size is 10. Means it contains 10 records. Now we'll merge these three files. We'll use two-way merging. So first we'll merge two files, then the resulted file will merge with another file. Let me first merge F1 with F2. F1 contain 5 records, F2 contain 18 records. After merge, the new file will contain 23 records, or we can say there are 23 record movement. Next, this 23 I'll merge with F3. Now new file will contain 33 records, 23 plus 10. Total number of record movement equals to 23 plus 33, it's 56. Is this the only way to merge? No, there are different pattern possible. Means first we can merge F1 with F3, then with F2. We can merge F2 with F3, then with F1, like this. Suppose I will merge F2 with F3. So 18 plus 10, there will be 28 records. Then I'll merge with F1. So 28 plus 5, it's 33. So total number of record movement equals to 33 plus 28, it's 61. 61 is more than 56. If we are merging F2 with F3, then with F1, there are more number of record movement. Suppose we will merge F1 with F3. So F1 size is 5, F3 size is 10. After merging, new file will contain 15 record. Next, I will merge with F2. F2 size is 18. 15 plus 18 is 33. Total number of record movement is 15 plus 33 is 48. So if I am merging less size file first, I am getting less number of record movement. So from this we are observing that first we need to merge the list size file. Here solution space equals to n factorial, or you can say total number of pattern possible is n factorial. These are the pattern F1, F3, F2, F1, F2, F3, F1, F2, F3. So these are some pattern. There are total n factorial pattern possible. Here size is 3, 3 factorial means 6. We can alter these two, means we are merging F1 with F2. We can merge F2 with F1, then with F3, like this. And total number of record movement equals to summation I equals to 1 to n fi di. What is di here? D means depth. Like for file 1, depth is 2. 1, 2. Then for file 2, depth is 2. Depth means distance from root to that file. And depth 3 equals to 1. It's 1. So file 1 size is 5. 5 multiplication 2 plus 10 multiplication 2 plus 18 multiplication 1, 48. Either we can add 15 with 33, or we can multiply file size with depth. Let's see next example. Example 3. 8 files are given. So first we need to arrange all the file according to increasing order of their size. F5 equals to 3, F7 equals to 5, F2 equals to 6, F1 equals to 8, F4 equals to 9, F3 equals to 12, F6 equals to 20, F8 equals to 30. Next I will create the tree. So first I will merge these two, F5 and F7. 3 plus 5. Now new file will contain 8 records. Next, I'll compare 6 with 8. 6 is less than 8. Then file 1 size is 8. This is equals to 8. So what I'll do, I'll merge these two, F2 and F1. 6 plus 8 equals to 14. Next, I will compare this 8 with 9. 9 is greater than 8. So I'll write F4 here. I'll merge this new file with F4. So 8 plus 9, it will be 17. I'll write 17 here. This is in between this. Next, I'll compare file 3, that is 12, with 14. 12 is less, so 12 will be here. We'll write F3 here. So F3, now new file will contain 12 plus 14, 26 record. I'll write 26 here. Next, I'll compare 17 with 20. So 17 is less than 20. So F6 will be here. 17 plus 20, new file will contain 37 record. I'll write 37 here. Next, I'll compare 26 with 30. 26 is less than 30. So I'll write F8 here, right side of 26. Now after addition, 26 plus 30, it will be 56. Let me write 56. Now I will add these two files, 37 plus 56, 93. So find the depth of each file. Depth of 5 equals to 1, 2, 3, 4. Depth of 7 equals to 4. Depth of 2 equals to 4. Depth of 1 equals to 4. Depth of 4 equals to 3. Depth of 3 equals to 3. Depth of 6 equals to 2, 1, 2. Depth of 8 equals to 2, 1, 2. 3 multiplication 4 plus 5 multiplication 4 plus 6 multiplication 4 plus 8 multiplication 4 plus 9 multiplied by 3, 12 multiplied by 3 plus 20 multiplied by 2, 30 multiplied by 2, total 251. Total number of record movement equals to 251. You can also add 17, 37, 14, 26, 56 and 93. This will also be 251. Anyway you can do. So you can add the number that's in the circle, or you can multiply file size with the depth. Let's discuss algorithm for constructing tree. For I equals to 1 to n minus 1, do pt equals to new tree node. Then pt left side will be list from the list. Then pt right side will be list from the list. Like here, this is the list 3 and 5. Now 3 will be left child and 5 will be right child. Next, PT weight will be PT left child weight plus PT right child weight. Like for this node, weight will be 3 plus 5 is 8. So its left child is list element from the list, its right child is next list element from the list, then its weight is addition of these two. Next, insert this PT, this 8 into the list. Like 3, 5, 6, 8, 9, 12, 20 and 30. So we'll add 3 and 5, result is 8. We'll insert 8 here. Next we'll add 6 and 8, result is 14. We'll insert 14. Next we'll add 8 and 9, result is 17. We'll insert 17 here. Next 12 plus 14 is 26. We'll insert 26 here. Next 17 plus 20 is 37. We'll insert 37 here. Next 26 plus 30 is 56. We'll insert 56 here. Next we'll add these two, that is 37 plus 56, it's 93. So whatever addition we are getting or whatever weight of the new node, that again we are inserting in the list. And we are moving left to right in the list, and every time we are adding 2 to node. Now what will be running time for I equals to 1 to n minus 1. So n time it is running. How the list is given, whether it is in array format or it is in a mini format. If it is in array format, then it will be order of n. Total running time will be order of n square. If it is in min-heap format, then to insert in min-heap, time take is order of log n. So total time will be order of n log n. So based on how the list is given, whether it is in sorted array format or a min-heap format. If it is a sorted array format, running time will be order of n square for constructing this tree. And if it is in min-heap format, then running time will be order of n log n. N time we are running, and for one insertion running time is log n. So order of n log n. With this, I am finishing optimal merge pattern. In next lecture, I will discuss Huffman coding. Optimal merge pattern is required for Huffman coding. So first go through this lecture, next follow the Huffman coding. And if this lecture is helpful for you, please like, share and subscribe. Thank you.